4.4 Properties of logarithms. So there are three properties listed here. The product property, which states that if you have the log base of a multiplication problem, you can separate the two terms being multiplied into two separate logs by an addition problem. The quotient property states if you have two terms being divided as an argument inside one log, you can separate them with subtraction, taking the log of both again. And then the power property states if you have a log and the argument has an exponent, you can, what I call fly the exponent or bring it down in front of the log so that it's no longer an exponent. So keep in mind, you must memorize these. Now, something also to point out, because this is a frequent mistake, notice how you don't ever take the log and add to make it into two logs in an addition problem. And you don't ever take one log and divide them and make it two logs and divide the terms. So that's a common mistake that we see a lot. So just make sure that you don't make that. So note that difference. Okay, so if we look at these example problems, the first one is an addition, two logs being added together, which follows the product property. So we're going to write them as a multiplication problem. So we have log base 2 of 7 times 5. And when you can simplify, we want you to. So that turns into log base 2 of 35. And that's our final answer. So the second example are two logs being separated by subtraction. Now it's the natural log, which follows the same properties, so we just write ln instead of LOG. So we have ln of, now the first argument always is on the numerator, and the second is always on the denominator. Now this is our final answer. You cannot simplify it, so don't. Down here, C is another one, but before we can do anything, we have this 1/2 right here. So we're going to make it an exponent. But then, if you note that if we rewrite it as minus log x to the 1/2, this is the same as saying the square root of x. So we can completely get rid of that exponent. So we're going to make a division problem with one single log, just like the directions say, x minus 4 divided by the square root of x. D has the same thing going on. We have this 2 here, and then so we can write ln x squared plus ln, and then this is just x plus 6, so we can't do anything with this. But we can multiply them. So we have ln x squared times x plus 6. So this shows the product property, and we can actually keep going and write ln of x to the 3rd plus 6x. So this whole thing becomes our new argument. Okay, the second part is just using the power property so that we can rewrite each term as a product. So instead of having an exponent, we're going to bring it down in front, which in the end is multiplying. So we write x times ln of 5. Over here we have x plus 2 times log of 32. Again, over here, this is saying x to the 1/2, so that 1/2 comes down. So there is, even though there's a square root, there is an exponent there. And then this last one is going to be 5 times log base 2 of x. So now what we're going to do is we're going to write the logs as a sum and difference. So you can either be asked to condense a log into writing it just with one single log, or you can write a sum or difference of logs, which would be expanding it. So for this first problem A, there's multiplication going on. So we're going to make it using the product property. So this would be log of x squared plus log of z. And then we have that exponent, so we do have to bring that down and write 2 log of x plus log of z. Now over here, question B, this whole thing is pretty much being taken to the 1/2 power. So we need to actually fly that exponent down first. So we're going to write 1/2 ln of the argument x over x plus 5. So we still can separate that, but now we have that 1/2 here. And what that does is it tells you that that 1/2 gets applied to everything, even when we separate using the quotient property. And you can either do this, or you can distribute it and write it twice, just like that, because you distributed it. Okay, C. C is quite involved. But you just have to note what is a property and what is not. So the first thing I see is the quotient property. So I'm going to write it as ln of E, and then I'm going to change that root into a power of 1/2, all at the same time. So these are the two things I'm doing. Minus, because we're dividing, by the argument 2x plus 5. So the next thing that I see that we need to separate is this product property right here. So we're going to have ln of E plus ln of x squared plus 1 to the 1/2 minus, now this 3 can come down, and then we actually also need to bring this 1/2 down. And if you can do multiple steps in one, like we could have brought the 1/2 down in the last step, that's fine with me. Just make sure you take it step by step if you need to. So this is as expanded as we can get, but we always simplify if there is something to be simplified. So you know your common logarithms now. ln of E is 1, because it's like saying E, this base down here that we don't write, but E to the what is E? 1. So this, in blue, is your final answer. Okay, and then D is very similar. That 3 comes down in front of everything. And then we have, I don't know why I wrote 5. Then we have the quotient property. So 3 times the log of x minus the log of y. Okay, so the change of base formula, this is frequently helpful when we don't have a base of 10 or e, because in your calculator it only lets you do it in 10 of e. Now, some of them allow you to do it in the calculator. Some of the fancy calculators or the newer ones can change the base for you, but it's more efficient to use the change of base formula with log or ln. So, essentially what you do is you take your argument and your base and you change them into a quotient problem. And I always say the base goes on the bottom. So for example, A, you have log of 29, and then the base of 3 goes on the bottom, log of 3. And when you do this, you get about 3.065. Over here, B, you have log of 3.6 divided by the base of log of 5. And again, we have 0.796. Okay, it's also important to know the fundamental properties of logarithms. So when we do this, it's easy to see these properties when we convert them into exponential form. So we're actually going to convert the 3 to exponential form, and we're going to convert this bottom one, number 4, into log form because it's in exponential form. So we just convert it into whatever we don't have. So this one is b to the 1 equals b. Well, we know this, so this is something that you need to start to know. Log base b of b is 1. So when the when the base and the argument are the same, it's going to give you 1. And then when your argument is 1, because b, which is anything to the 0, equals 1, so when your argument is 1, you're always going to get 0. We need to know that too. Now here, again, we're doing the popcorn method, so we can I'll write it over here, b to the x equals the argument b to the x. So this is like the uniqueness property, so we have x equal to x. And then for that log, since it's in exponential form, we're going to rewrite it in a log. So log base b of x equals log base b of x.